Right, you are live. Anybody ever shows up, somebody will give you a voice.
Yeah, as soon as somebody shows up, give me a voice check. Got back from Eva's treatment, so running a little late.
Yeah, well, so far it's not showing.
I know, that's why I wanted to get it set up 45 minutes ago, and but it. Anyhow, I don't see anyone here yet, which doesn't surprise me. Just, I'm not even sure. Is there any kind of notification going out of the way? There's somebody. Hey, Mr. Virtue. That's your first one. Oh, yeah, we're running a little late because Eva's treatment ran a little late,
Hi, everybody.
thus such. So, um, as soon as she got everything ready to go, just fired it up, see what happened. Anyhow, this week we had primarily, still haven't gotten any assays back from the lab. Hey, John, how's it going? Um, the um, the lab still hasn't got us any answers back, so I really don't know all those experiments I did over the last week and a half, what the answers are. Hey, Jean Francois. Yeah, that is unusual for you. So, as I said, I really don't know what to say about those experiments I did because um, got no answers at this point. Don't trust the spot test. But um, got a couple of things ongoing here. First of all, here's the floor plate for the kiln. And this is that little Vivor kiln. Now there's a, can't find them on the market anymore. However, there appears to be an upgraded version with a different name on it. I forget what the name is. It's not Vivor. It appears to be the exact same oven with a different power supply section and control section. And it says it's rated at 2,000 watts and is 110 or 220 volts. So my guess is it's an upgraded um, version. You are Marvin the Martian today. Sweet. Eva loves Marvin. But anyhow, um, so it looks like a better unit. Okay, the one I've got's working fine, but more power doesn't hurt. And the ability to go 110 or 220 would be nice. Now, I can't tell very well from the advertising the details. However, Lauren has actually ordered one of these newer ones. So as soon as it shows up, we can kind of unbox it, check it out, make sure it works, and get a little more in the way of details on it. But let's say the actual oven part of it seems to be identical. The power supply module is bigger front to back. You can see the one I've got, it's basically flush underneath where the door opens. You open the door, then you're pretty much everything is flush. Whereas the new one, it comes out more to the edge of the door. So it's about another inch and a half thick front to back. So when we get one, get a chance to fire it up and see how it works, we'll have a better idea on that. I don't know whether we'll actually be using it for anything very quickly because Lauren's got a crap load of stuff to do this winter. So I'm not sure what his schedule is going to be like, etc. The assuming that the oven is the same, this plate should fit it. So that's the assumption. Now, here's one of the uh, molds. I went and made 3 molds and 3 base plates because one's for Lauren, one's for Central America, one's for me. And this is for Jared down in Central America. Jay is also for Jared. And it works pretty simply. The refractory I use this time is a what do you call it? Oh gee whiz! I gotta turn off the upside too. Let me put that here to remind me. I've got the base plate in mind cooking at 600 centigrade right at the moment, just to drive any moisture or anything out of it. But anyhow, so in theory, this should work. Assuming it's the same furnace, the same oven, it'll work just fine. We shall see. I know it'll work just fine for mine. I've got 3 molds I made and 3 base plates for now. The castable I've got here is Castable Fire Brick. Get the brand. It's from the local fireplace supplier. What I've used before is something called Satanite that worked just fine. This stuff takes longer to harden up. I mean, where it's got any strength to it at all. I tried, pulling one out of a mold after only about 4 or 5 hours, and it just cracked in. These, on the other hand, seem to be doing just fine, but I let them sit for 24 hours before I tried to pull them out. I also noticed in the forming the silicone part of the whole operation that the what do you call it? The silicone, what's its name? Montana too. Oh, I forget it. It lives up there by Steve. Yeah. Dale. His last name's Andrew. But anyhow, he does stuff like that. He's got a supplier he likes to use. I presume he gets it over the internet. Says it works great. Says it's an RTV silicone, like $6 a tube. Well, guess what? I didn't have a whole lot of time, so I just went down to the hardware store. I had 3 different kinds of silicone on hand before I started, and I used basically all 3 of them in the first mold, and they behaved significantly differently. The one that hardened quickest and hardest was the General Electric bathroom tub and tile 100% silicone, white. Okay. It hardened significantly harder, faster than the other 2. So that's what I used for the other molds and for something this size. Yep, Alan Robertson. That's the guy. Thank you, David. Seems like a nice guy. Never had a chance to meet him in person. But anyhow, yeah, exactly. That's who it is. And for this mold here, it took about 2 1/4, 2 1/2 tubes of silicone, but I made it specifically See how thick this thing is? So the mold itself is strong, and you can just lay it down on any flat surface, fill it up to the brim, vibrate it a little bit, and it'll work. And then when you tear it off the casting, it's strong enough that it doesn't get torn up. So I would imagine that these molds will last a long time, many iterations of many base plates before the mold is damaged unless you do something. So that's what I used, and it seemed to work well. It's not as cheap as what Alan Roberts suggests, and I presume his works well too. I didn't have time to order anything yet. I need to get these things done. Jared's going to be here in a couple of days, and so I needed to have it ready so he can take it with him when he leaves here. And in a week and a half, he's going to be down in Central America. So a lot of my time was spent on this. I'm doing some other experiments where I'm trying to. This current experiment that's running is not determining, but it's testing the solids to liquids ratio. The exact same amount of crushed sulfide. It's the exact same amount of eco-golden, the exact same amount of hydrogen peroxide pretreatment in exactly the same manner. The only difference is, in one case, it's got a 2-to-1 solids to liquids ratio. The next case, it's got a 4-to-1 solid liquid ratio. And the next case, it's got an 8-to-1 solid liquid ratio. There are indications that will have a significant effect on the dissolution. Why? I don't know. Maybe it dilutes the stuff so that the equilibrium doesn't push back as you start getting more stuff in solution. I don't know. There's indications that. What I'm trying to do is get the parameters nailed down where I know I've got really good dissolution of the gold from the sulfides. That includes pretreatment, the amount of eco-goldex, and the time of dissolution. So these things I'm trying to nail down solidly now. There's also been other stuff like looking up the links, making lists, and everything of all the stuff they're going to need down in Central America to do all this stuff. So that takes a bit of time too. And of course, taking care of Eva and other, the usual stuff you have in life. So haven't had a chance to do much. They just run that one experiment, solution stuff. Another one I'm running. I've got a fair amount of loaded solution, pregnant solution. And what I'm doing is taking 4 grams of max water resin and I'm using it to store about 1.3 liters because that's a comfortably full bottle roll there. And what's the brand on that, Jean-Francois? This particular one that I'm using, the newer version is about $4.50, and it's a little bigger than that. It's 5 1/4 front to back, 5 3/4 side to side, and 5 3/4 bottom to top. The actual opening, slightly larger than the tabletop, not by much. But anyhow, so I took a load of resin in there, bottle rolled it for 2 days, and then, like a complete blithering idiot, I forgot to take a sample of the Barron solution before I poured it into my Barron solution all-purpose catch container. I I've got the pregnant solution sample here, and I put another 1.5 liters in there, same resin. I'm trying to determine what's the maximum loading on the resin. How much gold will the resin absorb? Another important parameter to determine, how much resin you need, how long it go, stuff like that. So those are the two tests that are actually running on the bottle roll right now. Assuming that, hey Jane, assuming that the resin does a good job, etc., we can use it to, yeah, I was a blithering idiot, all right. Forgot that one. But anyhow, when I get the second batch out of there tomorrow night, it'll be another 48-hour bottle roll. I'll take a sample then, and that'll let me know whether it's kind of maxed out or not. I think he was talking about me, David. But anyhow, so assuming a few reasonable things, i.e. that the resin is getting there, fire assaying the resin will also be a method of determining how much gold came out of a particular batch of sulfides, and or just dripping the resin and smelting that down. So we'll have a method of determining how much we got that's fairly simple, but much harder to determine how much is still left in the sulfide. So I say it's really, really annoying not having a direct method like a reliable spot test. And so I'm hoping I can figure out a way to make the spot test or something similar reliable. We shall see. I mean, we got the copper strip test for the stripping solution, which works good. We need something on the actual leach, and I'm pretty sure we'll figure out something sometime, but I'd like to do it fairly quickly if possible. Another issue they were having down south was that the 100 mesh screen on the end of the ball mill started wearing out very quickly. They noticed there was some pretty good size oversize being rejected from that screen. And it's clear from what was happening then that there was rocks coming out of the ball mill. You should never have rocks coming out of your ball mill. Okay. That's just not the way it's supposed to happen. Okay. So that indicates that it got overloaded, and so we're working on adjusting the feed rate and testing to make sure that doesn't happen. But that was interesting. That shouldn't happen. And again, I'm kind of waiting for Jared to show up. Got 2 batches of resin to run through the stripping circuit, and I'd like to do it through this stripping circuit because it's easier. The one I built for us down here does 3 cartridges at once, and you put assays on the computer and ask Chat GPT. I'm not sure what the question is. I'm not. It. I mean, I need to get the assays. The analysis I can do pretty easily. It's the actual getting the assays, and for that you need to have a sample that's run through laboratory procedures. Once I get the numbers, then I can do something. I'm just waiting for the laboratory to get to it. They're very busy right now. Things have just gotten really busy for them, and so it's causing delays process. Even then, a week and a half isn't too long for a lab to get some results. If I wanted to pay double the price, I could get them quickly, but I don't need it that bad. So, yeah, that's basically what's been going on. Eva is still feeling reasonably okay. Got 1 week of radiation treatment and two. Well, she had another one today, but two infusions of the monoclonal antibody uh, through, behind her right now. She's got just started on this week's of um, uh, radiation. Got another infusion today. I guess she's going to have a total of 8 infusions. Got 5 more weeks of that, and about the same for the radiation. So she's got a ways to go. The assumption, and not so much an assumption, just pretty much a solid prediction. Her comfort level is going to go down from here for a significant period of time before it turns around and starts back up. So it'll be after the infusions, radiation stop, probably weeks to months after that before she really starts improving how she feels. It's if you're talking about Eva, it's 5 radiation treatments a week, 1 a day for 5 days, and 1 infusion a week on Mondays. They also do blood tests on Mondays, and they consult on. They'll do the blood test. They'll look at the blood tests, then they'll talk with her, and then we do all that. If you're talking about the laboratory samples, um, then it's kind of when they're doing a particular kind of sample. The gold testing is metals, and that's not the thing they do the most of. They're set up for it, but it's not something they do every day. And so it's generally going to it's going to have a unpredictable thing. It depends on what other people are bringing, what they are. With taste, yeah, say with respect to Eva, it's not one test. Say it's 5 radiation treatments, weekdays, new radiation treatment each day, and every week she gets an infusion on Monday. Okay, and then there's also some blood testing and stuff that goes on Monday. Blood tests are doing just fine right now. Eva's, not really feeling terrible at the moment yet, but we'll see how it goes and like that. But at the moment, it's not bad. As the man said, as he past the 10th floor of the Empire State Building on the outside. It's going good so far. So we shall see what we shall see. But at the moment, it's not bad, but it wasn't anticipated to be bad this early. Somebody just sent me a message. One of you gentlemen. Thank you. Your bill. T-Mobile. T-Mobile. Is that supposed to be paid automatically, little one? It says T-Mobile. Hi, Keith. Your bill of $116.49 is now available. Auto pay is scheduled for 12/25.
Okay, so it's just telling you that your new
It's
bill
just a
came
notification.
out. Okay,
Yeah.
don't scare me like that.
No, I'm just checking it out. Anyhow, you might want to poke your face in there for a second, say hi and wave.
Hi, everybody.
That's not a face.
I are still here.
That's a hand.
I am getting a rash. I am beginning to look like a teenage boy. They can stuff it.
Yeah. No, it's just a notification. That's who we get for that. That's who we pay our cell phones and stuff on. Anyhow. So anyhow, I say that's kind of what's going on, and it hasn't been a real hugely productive week or whatever because again I've been doing some stuff that isn't really that dramatic and waiting on lab results before I do much of anything else. I want some guidance. David says the goddess all bow down. Jeffrey says love you, Eva. You know. So
Well, let me put it this way. If he covers the camera, I will continue to be the disembodied voice here. No, seriously, guys. I really don't want to be on camera right now. Once it gets so bad that I have given up all hope of looking like anything other than dog snot, then you will see me. Yeah, I did his haircut. I always do.
yeah. But anyhow, so as you can tell, she's still got energy. That's basically what's been going on here, and say we shall check the new kiln and how it works. I mean, I don't even know what kind of plug it has on it. 110, 220. What's the plug? You know, how do you switch over from one to the other? You know, do you have two different cords with a? David says great Terry anyway. Yeah, I said I don't know. I don't know how it's all set up. But we'll figure that out once it shows up over at Lauren's house and let y'all know so that you can evaluate it for your own purpose. Hey, if it works as good as this VVOR is, we'll be really happy with it. May work better.
And the goddess says, buy silver.
The voice has spoken.
Y'all best be buying silver. Serious.
Yeah.
Things are getting crazy.
There's a lot of crazy, that's for sure. Yeah, I'm just really not sure how they've got that figured out. David. Take care, Jean-Francois. Thanks for showing up. Take care. So, yeah, that's what's going on. And my big issue right now is figuring out exactly how best to dissolve the gold out of those sulfides. It's also unclear whether somehow we have two different samples or whether we're getting different efficiencies of dissolution or what's going on. It also maybe I just need to run it longer to make sure I get it all out. I don't know. We shall see. Also, Jeff Kablock has messaged me a couple times, and he's really eager to get going this summer. So I'm anticipating a busy and interesting summer this year. And we'll go from there. He's got, I think, something like 4 hard rock mines and 2 placer mines in the same general area. So it'll be interesting how that gets going there. Or buy a 600 and then sell for 1,200. Possibly. I'm not sure what it's going to do. As far as I can tell, the physical silver is a whole lot less than the paper silver that's been sold. And I have no idea how that would shake out if it started going sideways. My guess is the price of silver would really skyrocket, but I'm not sure to what level. It's technical stuff that's beyond me. Also, this whole Europe, Ukraine, and everything thing it looks like the Europeans are intent on confronting Russia, and it looks like Trump doesn't want to go head to head with Russia for good reason. I mean, global thermonuclear war and things like this. But the Europeans, some of them, leadership has said that if the United States leaves them in the lurch, so to speak, they're going to sell all the U.S. Treasury bonds they hold, which is like $2.5 trillion. And that could have quite the economic impact. Now, I think it'd probably be mutually assured destruction for the Europeans, but that doesn't mean they're not motivated enough to do it. But I don't know. The whole thing looks a little crazy to me over there. But when they're threatening to sell U.S. treasuries, that could have a significant impact on us. I'm not exactly sure what the situation's going on with Japan, South Korea, China. I don't have the time or the expertise to do a lot of research on this, keep up, but you're getting significant reporting that all of those countries are potentially economically unstable to a certain extent. I mean, it's just not good, solid. And so who knows what can happen there. Same thing. As soon as the global economic system starts having trouble, it could really make the precious metals go crazy. I tell you. One person, I'm not sure who it was noting that it's a rather unusual time in history in that over the past 1,000 years, whenever you've had a global power that overextended itself economically to the point of collapse, whether it be the Romans, the Spanish Empire, or the British Empire, or the whatever, the Byzantines, there was always somebody else in the wings, healthy and ready to take up the slack. In this case, the person hypothesized that that's not the case. All of Europe is economically in trouble. The United States and Canada are economically not stable, and therefore, and China's not stable, and Japan and stuff. I said, well, everything could everything else out. The one thing that they left out of there that I think is significant is Russia, because Russia collapsed in the 1990s, and they have pretty much got back on their feet. They've got a debt to GDP ratio of 14%. We're 120%. And all of these sanctions they've had to deal with over the last few years have pretty much motivated them and or forced them to become self-sufficient. So, I say, it could be that the winner of this whole kerfluffle might very well be Russia.
Okay.
It'd just be hilarious.
Anyway,
Uh-huh.
so
What?
Anything else going on with mining?
I know some stuff I can't discuss. There's some significant things that are going to be going on in this general area here, not us. I'm talking significant stuff. But as far as I know, it hasn't been press released yet, and therefore I'm not at liberty to discuss it. But there's some major stuff in the works around here. The whole economic kerfluffle with China has caused the Trump administration to put a heavy emphasis on becoming independent in rare earths as soon as possible. Basically, it's a national security emergency, which means that a lot of regulation is simply, who cares? Mining rare earths in the United States shouldn't be much of a problem. Processing may take longer to bring up to speed. Again, I'm not thoroughly versed in the details, but I mean, we did the Manhattan Project in what, 2.5 years, something like that. I don't think that rare earth refining should be significantly more difficult than that. So I would expect to see, by the end of the Trump administration, a pretty robust domestic production of rare earth. In the meantime, there's going to be a lot of emphasis on that. So you might wish to keep your eyes open for opportunities there, either as a prospector or as an investor. There is a significant push to become independent in rare earth. So that's an interesting tidbit. Aside from that, don't know much in the way of mining news to relate. Say there's some stuff that I'm sure within the next 6 months I'll be able to tell you some really interesting things. Okay, but I say it's an interesting situation. I don't know. The whole situation is just so complicated and unstable. I don't know what about the overall stuff. Personally, I'm just not that terribly busy with stuff. I'm busy taking care of Eva, taking care of some other stuff that got to take care of. But in terms of mining stuff, until I get some lab assays, I'm not sure exactly what's going on. So I don't want to just keep putting forth a lot more effort. I've got those bottle rolls going now for time. Took samples at 24 hours and ship them out. And once I get them back, whenever that is, I can take samples of stuff that's been running for days. Uh, I'm not sure what it is right now. I'm probably in the neighborhood of 5 or 6 days of bottle rolling. Um, and still got plenty of Eco Gold X. pH is fine. Oxidation reduction potential looks normal. Um, so if it's still got gold in there to be leached, it should be leaching. We shall see. But that seems to me to be the most useful use of my time at this point. Just put some hours on the clock, so to speak, so that I've got when I get samples back from the lab, whatever they are, I can take more samples from a week of agitation later and compare them, see what happens. They were not able to get me more samples down south this trip. In a month or two, I think they're going to have their export license. Something should make that fairly simple. But that's kind of the situation there. Anyone else got any questions or subjects or anything they want to discuss at this point in time? Hadn't been a terribly newsworthy week for Hard Rock University. Lauren's got another couple of days up on the mountain before he's pulled out. And then we may have stuff going on at the place. They will check out that furnace, tell you what's what on that. But that's what's happening. I appreciate everyone sending prayers and good wishes to Eva. At this point, we're getting along okay.
Next week I gotta order.
Okay. Say, physiologically, she's doing okay. Mentally, she's hanging in there. Economically, we're doing okay here. A copper anode and cathode in the stock pot to speed up the cementation. I guess you mean the electrolytic cell. I wouldn't go with the copper cathode that much, simply because the gold likes to plate pretty strongly to it. Stainless steel as a cathode is easy to clean the gold off of. Copper, not so much. The atomic / molecular / crystal structure is such that the gold latches on pretty solid. In terms of using a copper anode, I don't see where that would be a terribly harmful thing to do. You're going to get more copper in solution, and it's going to disappear on you. With this particular electrolytic cell I've got, I made a set of steel anodes to replace the carbon ones for testing purposes and see what happens. I was had a little communication with Pine Research, who's electrochemist stuff, and the surface resistance of the carbon anode is going to be higher than a mild steel anode because the carbon is a bit hydrophobic. So the question was that I asked them basically is, I've got these new carbon anodes, and it looks like I have to push the voltage significantly higher in order to get the same results in terms of amperage. And they're like, yeah. Not surprising. So depending upon how many days Jared is going to have to spend here, if he can spend 2 days, then I want to do 2 sets of resin, because I can strip the resin in less than 24 hours. So my thought is, if he's going to do that, we can go ahead and I can strip these last 2 batches of resin, no problem. And while I'm doing the stripping, I'm going to swap out the carbon anodes for steel anodes. I'm going to do a few things. First of all, I'm going to test what is the natural cell voltage. In other words, no induced voltage at all. Carbon, stainless steel, what's the voltage between the two? Pull out the carbon, put in mild steel electrodes, what's the voltage between the two? Because it'll act like a battery to some extent. And if the voltage from the carbon anodes is in the wrong direction, it's going to be fighting the induced voltage. So I'm going to have to add voltage just to overcome that. If your standard carbon zinc cell, the old flashlight batteries, put out 1.5 volts, and all it was carbon and zinc and an electrolyte. Well, I've got carbon and stainless steel and an electrolyte. It should be a battery. Okay, so I need to check it. I just don't want to put it all together until I'm ready to use it. Okay, and until I can talk to Jared, get an idea when he wants to be here and how long he's going to be here, then I don't really want to just set it up and get it going. But the next time I set it up, I'm going to be testing the natural cell voltage of just carbon to stainless steel and the mild steel to stainless steel, and go let's say using copper, I don't think is going to make any difference that you can't achieve simply by adding more voltage. Okay. And when you say, even if you handle around 2 or 3 volts with the mild steel anodes, stainless steel cathodes, we were only inducing 0.35 volts, and we were getting current flows of up to 2 amps, plating out stuff. This particular cell that I've designed has more surface area in it. So theoretically, if you had plenty of stuff, you should be able to plate at even higher amperages with the same voltage. But the carbon anodes are behaving significantly differently. So I need to do some testing and figure out, with the carbon anodes, A, do they work just as well if you got them adjusted right? Or is it better to go back to sacrificial mild steel anode? It's certainly doable. We did it many, many times. The negative is, A, it corrodes, and B, it puts iron in the product. They prefer to have a cleaner gold and silver debris from your cathode than with a lot of iron. Now, it's easy to remove the iron, just hydrochloric acid or nitric, not both at the same time, or potentially just the smelting flux. If it's not too much iron, the flux itself should remove. Yeah, we shall see what we shall see. But just, I don't want to fire it up until I'm going to finish off these 2 cartridges. Because after that, I don't need to move any more significant, strip any significant amount of resin past that. I mean, I'll be talking, 10-gram batches, 4-gram batches, things like that. Way too small for this system. he's going to be taking the electrolytic cell. So it's like, fine, take the electrolytic cell. I'll go ahead and just go back to little beakers like I was doing earlier, which is just fine for, a few grams at a time. Not a problem. But we shall see what we shall see. And again, I'm just kind of waiting. Theoretically, he was going to be here last weekend, but things got busy. You know how it is. Supposed to be here sometime this week. But we will discuss it. And once I've discussed it with him, then I'll have a good idea. Hello, Sarah. How's it going? And that's the basic hang up there. I also, when he shows up, this resin that I'm currently loading, could you use a gold anode? You certainly can. Okay, you could use a gold file. Well, not an anode. You would dissolve the anode. If you were plating gold, like for jewelry, yeah, you'd use a gold anode. The jewelry would be the cathode, and you would have a high strength gold containing solution, like a gold cyanide solution with a few additives. She's still doing okay, Sarah. We expect her condition to become significantly less pleasant over the next couple of weeks. But hey, with any luck, it'll work. Got a good shot. But she's doing okay so far. And we will see how she's doing next week. But she's hanging in there just fine at the moment. See how it goes. But anyhow, if you're, let's say, if you're plating gold like in a jewelry situation or something like that, another thing you could use would be a non-sacrificial anode of some sort. I'm not sure, maybe titanium, maybe carbon, whatever. Then your gold is just in the solution and you're plating it. What I'm doing is basically electrowinning, direct electrowinning of the leaching stripping. And I prefer not to get, I don't like sacrificial parts if you don't need them, because it's just a maintenance issue that, if you can avoid a maintenance issue, you're avoiding a maintenance issue. And also you're contaminating your product. So that's why I went to the carbon anodes. See how it works. It may be one of those improvements that you're best not doing. There's been numbers of times throughout history where somebody comes, well, this should make it work better, and it didn't. Yeah. Believe me, I would not be the first one if that were to be what happened. I'm very comfortable, though, knowing, yeah, I've done it with sacrificial steel anodes before, and not terribly worried. Anyhow, can't think of anything else. Good question. One thing where the copper works real good is precipitating silver out of silver nitrate solution. Silver nitrate? Yeah, it was. We dissolved it in nitric acid and then precipitated from there. Could you selectively cement gold? It can be done. Yes. I'm not sure exactly what the voltages are, and again, it would depend upon your electrode materials, but you can certainly do that. In the case of electrolytically refining copper at copper mines with the matte copper they make, They turn them into anodes and electrolytically refine them. One of the metals, gold or silver, I forget which, stays in solution. It goes into solution, and the other one winds up in the anode sludge. So they do it that. But yes, you can definitely by using proper chemistry and voltage, you can selectively plate. Absolutely, it can be done. In our case, we probably just want to plate everything for the moment. Hey, Shane. Um, I'm presuming that over the intermediate term, we'll just be selling Doré gold, and the silver will just get gigged partially for the silver. If they want to gig us too much, then we'll either sell it to someone else or worry about refining it. You can electrolytically refine the gold, or by using a selective voltage, proper chemistry. Again, you can do kind of the same thing. The gold goes into solution and plates, and the silver winds up at the bottom of the cell, so to speak. Or you can chemically refine it. You can dissolve it in aqua regia and then precipitate it with sodium metabisulfite, which will give you a much cleaner gold. You can also in-quart 4 parts silver to 1 part gold, then dissolve in nitric acid. Then you can precipitate your silver from the nitric acid with copper to cement. There's ways you can do it. In a real production setting, it's often simplest just to sell the Doré and take a 1 or 2% cost. I'm not sure what you're talking about, Mr. Bird. You rotate the dirt to get the hard rock out. I'm confused. I'm not sure what you're trying to say there. But refining gold, generally refining gold by yourself. I mean, if you're like Street Tips, you do it for fun and for video content. If you're a miner and you're just looking for money, it's quite often fairly straightforward just to sell it. The big refiners, I know, only charge you like 1 or 2% as a refining. Smaller ones I've seen up to 10%, or if you give them 90% gold, they give you 99.999, but they only give you 90% of what you handed them in actual gold. Again, it depends on your situation. The other thing you have to be careful of if you're using a refiner is if the refiner pays you for it, now taxable income. Okay. Can you sell the ore? It's entirely possible to do so to custom mills and things like that. It's generally going to have to be pretty high grade to make that economically viable. But if you had 5 ounce to the ton ore, it can be done. It used to be very simple in Arizona because in order to smelt the copper, they needed a bunch of stuff for flux. One of the things they needed for the flux was silica. Another name for silica is quartz. So if you had a quartz ore with gold in it, you could take it to the mill, the smelter, and sell it to them, and they would often pay you 95% of the gold value. And you didn't have to do anything. Just mine it and haul it to them. It was a heck of a nice deal. And then they've chased all the smelters out. $94 to 97%. That's not bad, Shane. That's not bad. Fairly pure. The stuff we got over there at top of the hill, it's less than that. That's for sure. But yeah, it was really nice in Arizona for a while because you could just take your quartz, assuming it had enough silica and it didn't have any nasty stuff in it that would screw them up. It was a real sweet deal. Just mine your quartz and sell it. Mine it, haul it, sell it. Piece of cake. How come they chased the smelters out? Primarily, it was environmental considerations. In the beginning, it was very legitimate. Smelters, when they took the sulfides, which is what they processed, the copper and copper iron sulfides like chalcopyrite, chalcocite, things like that. In the smelting process, all that sulfur became sulfur dioxide gas. That's why they had those huge smokestacks, sometimes over 1,000 feet tall. So they get that flue gas up into the airstream and it would blow downstream and disperse before it came back down to Earth to a certain extent. It wasn't highly efficient at doing that. And they just put an enormous amount of sulfur oxides into the atmosphere. Nowadays, a smelter will use an enriched oxygen flash furnace to produce a flue gas that is so rich in sulfur dioxide that it can be converted directly to sulfuric acid. And so not only does it clean the exhaust very effectively, but you now are producing thousands of tons a day of a chemical that can be used for a lot of stuff. In the case of southern Arizona, one thing you can use a whole bunch of cheap sulfuric acid for is to leach copper out of copper oxide ores, which in the old times, the copper oxides, the turquoise, the chrysocolla, things like that, they were just thrown away. The oxidized zone of your ore body was just waste. It was dug up and moved off to the side to get to the sulfides that they could then crush and float and smelt. But once they had huge amounts, the Hayden smelter, I just happen to know the number on this one, was producing 6,000 tons of sulfuric acid per day. Okay, 6,000 tons per day. 60 rail cars of concentrated sulfuric acid per day. That's a lot of sulfuric acid. And then they found out they could take that, pour it on these old dumps, leach the copper out of it, then extract the copper from the dilute sulfuric acid solution. And it was actually costing them less money to do that than it was to mine and process the other copper. So you wound up with a situation where environmental concerns, which then became regulations, but in the old days, they used to be reasonable regulation. Okay. And, but it turned into a win-win. You cleaned up the environment dramatically. We had, I don't know, a dozen big smelters in southern Arizona at least. Okay. Each one pumping thousands of tons of sulfur dioxide gas into the air every day. So, cleaned up the air dramatically. We produced a useful byproduct, and we now could efficiently extract the copper out of material that used to be just thrown away. So now we dramatically improve the efficiency of the copper mining and reduce the costs. Win, win, win. Cleaner environment, more copper with less environmental disturbance. A smaller hole in the ground gave you more copper. Win, win, win. But they take these environmental regulations to such extremes that, for example, we do not smelt our own lead in this country. We got some really good lead deposits in the Midwest, the Great Plains area, I think Kansas or somewhere around there. Really good stuff. And we had our own smelters, but they got chased away. So now we have to buy it from like China. We have to ship our lead, our galena across an ocean, get it smelted, and then bring it back. Or
smelted by cartel run operation.
Or ship it to Mexico and give the cartels a cut. Yeah, it's just do it ourselves. We can do it reasonably clean. I don't know how many of you folks were alive and running around in the 60s and stuff. Yeah, we had serious pollution. Whenever we had to go to Los Angeles, my eyes didn't like it because it was nasty. Your eyes would literally burn because of the pollution. You don't see that nowadays. They say, oh, it's a critical air pollution day. And it's like, yeah, right.
Grandmother in Lincoln, Maine, 2/3 of the town, children, had emphysema and COPD and other lung conditions because of 3 large paper mills. They called it the smell of money.
Yeah, that's it. There was serious environmental, call it abuses, back then. The Cuyahoga River in Ohio, was it Cuyahoga? I think it was Cuyahoga River. But anyhow, there was a river in Ohio that caught fire twice just because of all the hydrocarbons that were being dumped into it.
The Charles River in Boston had no fish in it except for catfish. Nothing else caught. In Boston Harbor, remember those 3-foot stripers you see? There weren't any when I was a kid.
When we went to Washington, D.C. in 1969, my mom and my brother and I, when we were at Mount Vernon along the Potomac River, there were signs every 50 feet, do not touch the water. Now it's perfectly safe to swim in. So the people that are, hair on fire about environmental damage, it's a lot better than it used to be. A lot better. And we survived that. Now, I don't think we should be stupid about it, but we shouldn't be stupid about things by being too scared either. So, as I say, there were a lot of abuses back then, and by and large, they were all corrected. But then the people who make and enforce environmental laws, wow, we fixed everything. Maybe we should get another job? No. We're going to make the standards tighter so that we have a job for the next 5 or 10 years. And that's a very human response to fixing a problem. Well, I can't fix the problem because if I fix the problem, I'm out of a job. Look at the, what do you call them, drug company. They don't want a drug that's cheap and will cure you because in that case, they don't make any money. They want a drug that's expensive and that you're going to keep taking. I have a friend, haven't talked to him in many years, but he wound up working on the Rocky Flats cleanup. Rocky Flats nuclear weapons facility near Denver. Yeah, like many other government facilities, they just sent it down in a hole, you know? And they created a lot of issues. Okay, I agree with that. But his job was as a hydrologist as part of the cleanup. And he called my brother up and said, you know, Randy, I think I've got job security. And Randy goes, what do you mean? He says, well, they just come out with the new target numbers here, you know, what we're trying to get this thing down to. And they want us to reduce the radiation in the groundwater to below background levels. Says, that's going to take a while. And that's the problem. There's no incentive for the regulators to be moderate, except economic incentives, and those can swing the other way. And so it's just a very difficult problem to come up with a good solution to, aside from people using their heads and following the science and the science of economics as well. And say, look, is this worth it? Like within, electric vehicles. Is it worth it? You know, we're going to spend a lot more money, and we're going to have to develop new resources and use those.
Scam.
We've got a new safety issue being lithium-ion batteries. When they decide to go wacko, they really go wacko. And we still got to charge it from something. You know, how's it going to be net zero if you're charging it from anything besides like your own solar panels? You know? Yeah, and solar panels, building them is not net zero. So, anyhow, you need to use your brains and look at reality rationally. They're starting to start talking about, you know, we need to start building a lot more nuclear plants. There's a reason for that. It's the only efficient way of generating large amounts of electricity that doesn't create carbon dioxide. Is the juice worth the squeeze? Yeah, that's pretty funny too. Yeah, juice. And another thing that's not as well known, but when you have alternative energy sources, wind turbines, solar plants, things like this, by and large, they generate electricity and then convert it to AC using electronic methods, okay? When you have a coal-fired power plant or a gas turbine power plant, where you actually have a physical generator that's spinning at a particular speed and has a lot of mass in it. So in order to disturb that frequency, it takes energy because you've got literally momentum in that generator. It's called grid inertia. Electronic power inverters and stuff, they do not have inertia. When Spain and Portugal went black a few months ago, that was because of grid instability caused by not enough, call it ballast, to keep it stable, you know? Oh, it takes silver, it takes
a
lot
lot
of other
silver,
things.
and it takes a lot of other nasty stuff.
You know?
I'll tell you, the goddess greatly disapproves of fake green energy. Nuclear power is good green energy.
Yeah, it can be done safely, and it generates a lot of power on a small footprint, and definitely generates a lot more energy than the carbon dioxide it took to build it. But a lot of these things are just the other way around. It takes more carbon dioxide to put it up and run it than you will save over the lifetime of that project. Why you got to go with the science. And yeah, it's very, very frustrating to see this kind of inefficiency. Now, yeah, and coal works good for making steel. Gas, natural gas does really well for things like generating power, making what do you call it? Cement. It takes a lot of heat to make cement, and things like that, and it just doesn't generate as much carbon dioxide per kilogram, per kilowatt hour than coal does. Now, I think that it's an unproven assumption that CO2 is actually terribly harmful too. Yeah, the emissions on a nuclear power plant are zero. Yeah. So, as I say, it's the emissions making the concrete and stuff like that. Again, cement, it takes a lot of energy to make cement. You got to heat that limestone up really hot. But yeah, they did study even back in the 80s with 1980s technology. And between nuclear, coal, gas, and solar, the greatest number of deaths per kilowatt hour was solar because of all the, it's labor intensive to keep solar panels working. People get killed maintaining them. Yeah, it was a total life cycle thing. Yeah. I mean, there's not a lot of mining in solar panels, you know.
There is in the earth.
Back then they weren't using rare earths and stuff. There was just silicon solar panels, and rooftop thermal collectors, to replace solar heaters. You had solar hot water heaters and stuff. But the next one was coal, because it has a coal-fired power plant a big one would put out 500,000 tons of fly ash a year. Limestone in general doesn't usually have much gold in it. Cement is made primarily from limestone, but there's usually some clay and a couple other smaller ingredients in there. But limestone's like over 90% of it. If you're making lime, then it's just pure limestone. Okay? You hear of anyone penning cement dust? No, I have not. Nuclear fusion. Not ready for prime time at this point. In the long run, if they can make it happen, it should be good. Another thing that people don't realize, though, is nuclear fusion also creates radioactive byproducts, because the reactor itself gets irradiated intensely with neutrons, and eventually the liners and everything else have to be replaced. It just, on an atomic scale, tears things to pieces when you hit it with that many neutrons over years. So then you wind up with these reactors, and the shielding around the reactors and stuff like that gets induced radiation into it. So if that doesn't produce no nuclear waste, in the case of a big, nuclear power plant, like 1,000 megawatts or whatever, it produces something like 1 cubic meter of nuclear waste per year. The high level vitrified waste ready for long-term storage. And that waste becomes less radioactive than the ore from which it was mined in less than 1,000 years. Okay. We can deal with this. Okay. It's not an intractable problem. Right now, nuclear fusion is, because we don't know how to do it. There's a lot of people working on it. but nobody's figured it out yet. And they're spending a lot of money. My guess is the person that finally figures it out is not going to be the government doing the big way, but somebody's going to figure out a way around it, like muon catalyzed fusion or something like that. But yeah, it's in the long run, fine. Until then, unless you want to kill a whole bunch of people, you're going to need to come up with some energy somewhere. And it ain't solar and it ain't wind power. Okay? Coal has negatives. Natural gas is a lot cleaner because a lot of it is hydrogen. So instead of just making carbon dioxide, it's making carbon dioxide and water. So that's less carbon dioxide pollution. Another advantage in power production of natural gas is it can be used to run natural gas turbines, which are essentially like the power section of a 747 engine hooked up through a gear reduction drive to a generator. And those things can be fired up in 5 minutes. They can be online in 5 minutes from the time you initiate the start sequence. They can be producing power in about 5 minutes. So this allows them to be very good for making up for swings in power demand. They can come online real fast. Hydroelectric dams, same thing.
Oh, cheer up. In another couple of years, we will be living in sea pod and eating bugs and being happy.
Not me. But anyhow,
Hey,
the
we have said so.
the coal-fired power plants, oil-fired power plants, what they call a thermoelectric generating plant, where you have basically big boilers. They're pretty efficient. They're over 60% efficient nowadays. But they also take several days to turn on. You know? Hydroelectric has negatives. They have found a way to make it less impactful. When you have a dam, it's used for two things. Diversion, in other words, it's guiding the water into the turbines, but it's also holding back a reservoir so you can either use it for flood control or to store water for later. But assuming you don't need that, they've got a new system that they've been bringing on over the last 10 or 20 years. Let's say you have a mountain right here, okay? Like the Himalayas. But you got all this snow and it's melting. So you got this fairly steady rate of water flow down. So you build a dam to divert this water flow. You don't need a huge reservoir because it's pretty darn constant. Okay? You divert that into a tunnel. The tunnel goes down here. Then you build your power plant down here. So the pressure that you need is generated by the slope of the mountains, not from the height of the dam and the amount of water it's holding back. So you can have tremendous power generation without a really big dam at all. And there's certain areas where these things make a heck of a lot of sense. And these tunnels can be 10, 20 miles long if they need to do that to make things work properly. There was one I saw in the Himalayas, and I mean, the dam wasn't any bigger than Hauser Dam over here, you know, which is only like 60 feet high. It wasn't much at all. All was there to do was to divert a certain amount of water into that tunnel at all times when they needed it, you know, and then they could open it up and let stuff go if they didn't. But you don't have the huge impact of a giant reservoir to make that power plant work. So that's another thing they can do that dramatically reduces the environmental impact, but it also makes it cheaper. This little small dam here is a whole lot easier to make than a big giant one. You know? And it gives you a lot of drop. I mean, I forget what it was, like 500 or 600 feet of drop on that one there. A lot. You know, that would take it ginormous dam. Nah, we don't need it. Just got a pipe. So that's another thing they can do. There's all kinds of ways. They're working on geothermal. When you're looking at lithium, the geothermal power plants over by El Centro, California, according to the internet, which never ever wrong. But anyhow, these power plants down there, these geothermal plants, they pump brine. Now I know that because I was actually doing some work with one of them at one time, so given a tour by the project manager and stuff. But they have a huge, just enormous amount of dissolved material in that brine that they're pumping up, running through to generate steam, then pumping back down in the ground. Well, it turns out that those 10, 12 power plants in a couple square miles are pumping up enough lithium just as part of the brine that they're getting to supply 10% of the world's needs. Just in that one little teeny spot. And that would just be a byproduct of what they're already doing. So there's times where you get these advantages. I think that geothermal in the long run has tremendous potential because it doesn't require a fuel or anything like that. As far as I can tell, the biggest problem with geothermal is getting the holes down to where you've got the higher temperatures that make for more efficient power generation. Okay, it's really hard to drill holes in rock that's getting soft from the heat. You know, but they're working on it. So I would expect that to start coming online in significant quantity over time. And again, it's something that, assuming that you can mitigate the complexities of getting the hot water up out of the ground, stuff on surface, it's standard technology. No big deal at all. It just will run forever, so to speak. It's going to take a long time for the Earth to cool down. So there's things that make sense, or that potentially make sense in the right situation and should be explored further. There's other things that are simply a scam to get tax dollars in the pockets of people who want tax dollars. You know, there's always people who, it's a lot easier to mine, and taxpayers, than it is to mine the ground or other stuff. As far as I know, they haven't had any problems like that over in Imperial. They're on a big fault too. They're right on the San Andreas. But when you're re-injecting the water, you're not adding anything. Now, initially, they would probably use hydraulic fracking just to increase the porosity of the rock. And there's the Geysers Project, Imperial and SoCal. I say there's a number of places where it makes reasonable sense, and is where you would start and develop the technologies. Iceland also does a lot of geothermal. So there are certain places where it might make a lot of sense. And that's where you'd start, you develop the technology, and then you can kind of expand it from there. But to put windmills all over the planet is not efficient. Money-wise, it's ridiculous. Same with electric cars. There are some places where an electric car makes a lot of sense. Okay? Most places, they're no better than a gas car and have certain negatives, like right here where it gets 30 below zero. So if we wanted to go from here to Missoula in wintertime, we're going to spend a huge amount of energy just heating the car on the way there. We'd just be throwing away that energy. Whereas with a gas engine, hell, 70% is already wasted. Yep. Yeah, I like geothermal. Ocean thermal makes a lot of sense. The problem is biofouling makes it technologically very difficult to accomplish. If you have, and they tried this in Hawaii years ago. In Hawaii, you have mountains. Yeah, dramatically increase the steep slope. Not the way it works. Here's the ocean level. And down here, the water is like 42 degrees Fahrenheit, something like that. And up here, it's 80 degrees Fahrenheit. So you got about a 40-degree temperature difference. So what you can do is you can take something like ammonia and pressurize it to a temperature where it boils at this temperature, condenses at this temperature. Okay? And then you can just use surface water as your hot side, deep water as your cold side. Getting it up there, you can even do something really fancy. I love this one myself. You put a reverse osmosis membrane down here, fill this pipe here with fresh water. The difference in pressure of salt water here, the fresh in here, creates the pressure differential you need to work the reverse osmosis membrane so that, because physics, the cold bottom water generates a stream of cold fresh water coming up the pipe and spewing out without any pumping energy at all. Once you put it in place, it just works because physics, you know. The problem with this is these reverse osmosis membranes biofoul pretty quickly. And therefore, it became just a maintenance nightmare here. You know, and this was pretty deep. I forget what it was, but I mean it was this pipe was miles long to get thousands of feet deep in the ocean. Okay. But you have a steady freshwater source. It's just generating fresh water forever. You know, you just have a valve to turn it off. It's giving you cold fresh water. You have hot surface water. So you can make power here, fresh water here, and there's no energy input. You know, there's no energy. If you want to go far enough away, it's like the sun heats ocean water, you know, heats water and refills the ocean. Yeah, it's going to take a long time for this to have any effect on the ocean. But basically, zero energy consumption. Fresh water, a lot of islands could use some fresh water and power. And this supply of cold fresh water is supplied at zero energy cost. Yes, it was tested in Hawaii. And I don't know, it was shut down at the time because of biofouling down here. These reverse osmosis membranes just got gunked up so fast that maintaining them was just ridiculous. And that was the problem. The rest of it worked fine. The theory worked just fine. I don't know how much power, because with only a 40-degree temperature differential, the power you're going to get off of that's going to be relatively inefficient. So the power plant part might have just been so inefficient that it wasn't economic compared to other alternatives. But it can be done. It was done on a test basis. This was decades ago. Again, it's not new technology. This is all old stuff. But there's always some little glitch like biofouling that makes it a lot more expensive or complicated than the piece of paper, or in this case, the whiteboard, shows. But yeah, there's a lot of possibilities out there, but we got to look for reasonable possibilities. I don't know what they tried to prevent the biofouling. You might have been able to coat them with silver or something. I don't know. All I know was that they didn't figure out a way to deal with it at the time. That may have changed now. You might be able to put ultraviolet light down there, something to that effect. I don't know. I haven't heard anything, I say, for 20 years. But they were trying it back in the, I don't know, 1970s, 1980s. There's a lot of stuff that's not being done. Instead, we're spending billions and billions and billions of dollars putting up wind turbines that, by the time you figure out the energy cost of making the materials, manufacturing the materials into wind turbines, shipping them to the place where you're going, putting the enormous foundations in the ground, take lots and lots of concrete, moving the crane and all the pieces in place, setting them up, and then maintaining them over the years, Yeah, I say there would not be zero maintenance, but it might be easy enough to do. I don't know. But I say, instead of doing that, why don't you spend it doing research here on geothermal, tide generation? I used to live up there by Puget Sound, and I'll tell you, there's a lot of current flowing in that sound on a regular basis. The problem is it's not steady. It'll go at 10 knots one direction, then it slows down to 0, then it builds up to 10 knots the other direction every, 12 hours? Low tide to low tide, high tide to high tide. I think it's 12 hours each. But nevertheless, so you've got a generator that's going different directions at different times and different efficiencies, and going to 0 to max generation to 0 to max, and that becomes a very expensive accessory that you have to put on there, is something to stabilize that power output, to store it and then release it, store it and release it. That's one of the problems with tidal power, that it's intermittent. In terms of direction, you can just make variable pitch blades. But yeah, one thing that they've been looking at doing is, in certain areas, you build a dam across a bay with big sluice gates, and as the tide comes in, it's filling the reservoir as well as running the generator. And then as the tide goes out, the gates close and force it back through the generators and such. And you could use battery storage, you could use pump storage. There's other ways of doing the storage than just battery, although that is one way. But again, storage, when they're talking about like photovoltaics and wind power, they never factor in all the other stuff you need to make it work. And you have a windy day and half of your wind turbines are turned off because they're making too much power. You know, it's that intermittency and the lack of the ability to control exactly when is the problem. I say this is the advantage of a gas turbine or a nuclear power plant, which can provide baseload, or hydroelectric, which can, provide peak load stuff on demand quite easily too. So there's lots of ways of doing that. Pump storage is actually a lot more efficient than I would have thought, where they just use big pumps to pump up into a reservoir and then run it back down through the same turbines to recover the energy, letting it out. It's actually pretty efficient. It's like 80% efficient or something, I think. If anyone knows, put it in the comments there. But it's reasonably efficient. Probably not quite as much as batteries, but surprisingly good. On the other hand, you have to have exactly the right circumstances to build pumps. Not something you build in the factory, haul out, set it. You have to have height, weight, a valley you can close off with a dam and all that other stuff. But yeah, we can fix it. Notice all of a sudden now that they're talking about all these big AI data centers and stuff like this, now all of a sudden, we can go nuclear now. Yeah, because the guys with the big money need the power instead of you and me. You and me, they're like, screw you guys. We're going to tax the heck out of you and then give you expensive power that's not reliable. But big data centers? Oh, no, no, no. We're going to give them power plants. Yeah. I'm getting a little cynical in my old age. Forgive me. Forgive me. But anyhow, so yeah, there's lots of things. They're all going to need a lot of copper. Although for those big transmission lines, I think they're mainly out of aluminum. I think because of the weight, tensile strength, and everything else. The big high tension lines, I think they're aluminum. Not certain. If anyone could correct me, that's fine. I'm pretty sure they're aluminum. But most of your distribution lines in town and stuff, those are copper. And so you're going to need a lot of copper. You're going to need, rare earths for magnet. You're going to need some lithium storage system. They're also working on new, what was it? Colorado? There's a new battery technology, new battery chemistry. And I forget what it actually was. It was like a sodium iron battery or something like that. There was nothing complicated about it. It didn't have the energy density of a lithium cobalt battery, but it had like 1/3 the power density of that, and it can't blow up, and it's cheap to make, etc. So for a stationary facility, like for your house, around here we have lots of houses that are out in the sticks, and solar power, stuff like that, make a lot of sense. You put in your solar array and your storage system and stuff, and you could use that as your storage system with vastly higher safety margins. Steel core. Okay, that would make sense. Yep. Thank you. But the lithium, it's needed for high power densities, which are required for transportation, because that battery, you have to carry it with you. If it's for a stationary system, let us say for a one of these big giant battery arrays that they're setting up to stabilize grid power and stuff with renewable. Weight isn't important. What matters is cost, reliability, safety. Okay? Can it blow up? Can it melt down? This apparently is vastly safer than lithium ion. It is 3 times the weight for the same energy storage. But you're using salt and iron, not lithium and cobalt. So it makes it a lot more economical and less environmental impact. We got plenty of those things. So these are the kind of incremental gains and breakthroughs that they'll just happen naturally if the government gets the hell out of the way and doesn't pick something and then subsidize the hell out of it and make regulations that require it, and therefore nobody can compete with it. Let the market do its thing. And one of the reasons that farm yields have doubled in the last 100 years, fertilizer's one, but the increase in the carbon dioxide level in the air is another huge one. Okay? At least half of those gains are just from the pollution we've been making. So, I say it's an interesting time we live in, but it's very, very frustrating to see reasonable possibilities go by the wayside by stuff that's provably not going to work, sucking up all the oxygen. It's just really frustrating. Say the electric cars, yeah, they're pretty much going to be gone in the next 5 or 10 years. There will be some. But right now, it's how do you get an electric car from China to the United States when nobody will put it on their ships? Makes it a little tricky. How do you drive an electric car if you live in an apartment if you're not allowed to park it in the parking garage? Makes it a little tricky. There's all kinds of yeah. Well, anyone didn't invent a home heating furnace that also makes electricity using the heat. Because turning heat into electricity is relatively inefficient unless you have a very hot heat. Now, your home heating furnace has a flame, which is fairly hot. Hello, Oregon. Hi, Michael. But the flue gas is relatively low temperature, and the methods for turning heat into electricity on a small scale tend to be quite inefficient. The advantage in home heating as to whatever makes heat. This is like for a hot water tank, hot water heater. That can be done using solar power also, and sometimes quite efficiently, especially in places like Arizona, places that have a lot of sun. It's not really, really cold. Yeah, you can use that to heat your hot water furnace. And by having the properly set up system where your solar hot water heater is generating hot water at, say, 115 degrees, or maybe even a little lower than that, somewhere around 110 to 115 is where it starts getting kind of dangerous for skin. And then you have backup gas or electric system that keeps it above 105. It gets below 105, the backup system kicks in. Aside from that, it's pure solar. And you can also have stuff where you have two tanks where your solar system is heating a tank that's then providing the hot water to another tank so that that tank can be at a more stable temperature. There's ways of doing this stuff. I used to work at a mine where we'd had the water tank was up on the top of that little mountain right there. Then we had black poly pipe that ran to the trailers. And what you do is you would turn off your water heater entirely. And at night, morning, you turn on your hot water until it starts running out cold because the pipe is now cool from overnight. Turn it off. Then the sun came up, these pipes got hot, and whenever you needed to have hot water, you turned on your cold water spigot because those black pipes in the sun provided nice hot water, and you would run the cold water as your hot during the day, and then when the sun went down and the pipes cooled off, you would turn that off and you would run your hot water heater that you had filled up during the day, towards the end of the day, for hot water at night. Then you'd switch over. So you'd be switching, morning and noon to morning and night to different supplies because one would, it would be hot 12 hours a day and it would be cold 12 hours a day. So you just switch. Worked fine. Saved a lot of hassle. But there's games you can play. Yeah, that can all be done automatically too. Anyhow, so that's what we've done this week. Not a huge amount, but there's a floor plate for a furnace, protect it. There's the mold, no problem. And these will be going down to Central America in the next couple of weeks. And gotta remember my note on the keyboard. Once I'm done talking with you guys, I need to go outside and turn off my furnace. I've been cooking my plate at 600 degrees, make sure it's really dry and really seasoned when I actually put it into operation. I'll be getting a better idea of how much the loading factor is on this resin fairly soon. And I'll get a little more of the loaded resin stripped. That's about it. Later on this winter, once I get everything I need to know, found out about this stuff in Central America, the sulfide cons, I'll be going back to trying other leaching chemistries to see what may work pretty well. Specifically, we're looking for reasonably good non-toxic chemistry that we can apply when cyanide or the EcoGoldex is not legally allowable. If it was a lot cheaper than EcoGoldex, that's another thing. Might be important. But we've got, I don't know, half a dozen potential chemistries I'll be checking out. Anybody else got any questions or subjects or whatever to discuss? For those of you who showed up late, Eva's doing okay right now. That's going to change as her treatment continues. But she got a good chance of beating the thing. So we're going to give her hell. She's holding up physically, mentally. I'm holding up mentally. Economically, we're doing okay. So it's just, as far as I can see, it's just going to be a slog. It's got a tough row to hoe, but I'm here, and she's determined. So I think we can get through this okay. And then next summer, we got some real stuff theoretically. the meantime, in the winter, I can stay busy doing research. So that's the evil plan. Any questions or subjects anyone wants to discuss at this point? Got 12 people still here. I appreciate everybody showing up. Hope it's been an interesting evening. And I hope I got more conclusions next week. The guy says I should have some results towards the early part of this week. So we shall see what we shall see. Hopefully so. So CLS 20 in 5-gallon buckets. It'd be interesting to see how it all works out. I tried the CLS 25. Didn't seem to work well for my particular application, but it was only a single test. And so that's one of the leaching systems I plan on getting back to. Be interesting to hear how it works out for you. Anything else out there? Well, I don't see anything. So I guess we'll call it a night. Appreciate everyone showing up. I was informative and helpful. So why don't we call it a night? Really? That's interesting, Michael. I may have to talk to them about that. I know that part of it is it's a confidentiality agreement. I won't even ask questions. But I know the people over there. Been there once, so I can talk to her about it and see what they got. All righty. Thank you, Michael. I appreciate it. Okay. I guess we're going to call it a night. So happy prospecting and keep it safe.